From the initial designs to the patient's final fitting, Korean engineers have shown off the amazing process of developing a high-tech leg prosthetic. Measurements of the residual limb are the first step in the process. To design a precisely fitted foundation, specialists use surgical accuracy to scan the limb's surface and shape. A customized framework is then created using three-dimensional models, accounting for the patient's weight, gait, degree of amputation, and even lifestyle. The production phase follows. A variety of cutting-edge materials are employed, including high-precision mechanisms that replicate the motion of a genuine foot and impact-resistant polymers. Each joint is carefully adjusted by hand to ensure proper biomechanics during walking. Once assembled, the prosthesis undergoes a series of tests. The reliability of the fastenings is checked, as well as its response to pressure, performance during walking, and resistance to physical stress. The structure is then covered with an outer layer, the so-called cosmetic shell. This can be silicone that imitates skin with an individually matched tone and texture, sometimes even with artificial veins and toenails, so that visually, the prosthesis is indistinguishable from a real leg. Some models are equipped with motion sensors, gyroscopes, and microprocessors that analyze the body's position in real time and automatically adjust the stiffness or responsiveness of the foot. After final assembly, the prosthesis once again goes through a full series of tests, checking the strength of its attachments, its reaction to pressure, how it behaves during walking, and how well it withstands physical loads. You are witnessing the incredibly complex process of creating hand prostheses for people with amputations. This is a high-tech and labor-intensive process of producing prosthetic limbs that help restore functionality to individuals who have lost their limbs. The first step in creating a prosthesis is a meeting between the patient and both the doctor and the prosthetist technician. This is an important stage during which specialists gather information about the patient's condition, the level of amputation, and their specific needs. To manufacture the prosthesis accurately, a mold is taken of the remaining part of the patient's arm. This is done using a special plaster or silicone material. The mold serves as the basis for further modeling of the prosthesis to ensure it fits perfectly in size and shape. The primary materials used to make prosthetic limbs are silicone and plastic. Silicone is used for the outer shell in order to create a soft, realistic skin texture. The internal mechanisms can be made from more rigid materials, such as plastic or metal, to provide strength and functionality. During the assembly process, the prosthesis is equipped with all the necessary components. If the prosthesis includes mechanical or electronic parts, they are installed at this stage. One of the most important aspects is the visual appearance of the prosthesis. To make the hand look natural, meticulous work is done on coloring. The silicone surface of the prosthesis is painted to match the patient's skin tone, taking into account features such as pigmentation, vein patterns, and moles. Sometimes, special paints are applied by hand to achieve maximum realism. Craftspeople pay special attention to details like fingernails and skin texture. Once the prosthesis is completed, the patient returns for a fitting. Specialists check how well the prosthesis fits, whether it is comfortable to wear, and how it functions. If needed, adjustments can be made to improve fit or functionality. The cost of such prosthetic limbs can reach tens of thousands of United States dollars, and many people are willing to pay that amount to feel like a full-fledged member of society. In a world where technology rewrites the boundaries of possibility every single day, a project has emerged that not only amazes, it inspires. Imagine this: a person loses an eye. This is not just a physical loss, it strikes at their sense of self, their identity, even their everyday communication. And now, thanks to groundbreaking three-dimensional printing, the process of restoration is not only possible, it has reached an entirely new level. For the first time in history, Australian scientists and engineers have developed a method for creating fully individualized artificial eyes using three-dimensional printing. Precise, realistic, and most importantly, fast to produce. Where once it took several months of manual labor to make a single prosthesis, the process can now be completed in just a few weeks. It all begins with high-precision digital scanning of the patient's eye socket. A digital model of the future eye is then created, taking into account even the smallest anatomical details. After that, a unique system prints the eye layer by layer, using biocompatible polymers and colored inks to replicate the natural appearance of the real organ as closely as possible. The result is so realistic that in some cases, it is nearly impossible to tell the artificial eye from a real one. Research is already underway on integrating sensors into the prostheses, which in the future could allow artificial eyes not only to look like the real thing, but possibly even restore basic visual functions. Engineer will cogly 3D printed an ultra-realistic human heart that is indistinguishable from a real one. It is powered by 3 servo motors controlled by an Arduino. Although the heart is essential for life, very few of us have ever seen one beating in real life. And since that usually requires serious trauma or major surgery, that is probably for the best. However, if you want an incredibly realistic working model of this vital organ, Will Cogley demonstrates how he created his own. The remarkable animatronic heart is cast in silicone and then coated with a type of artificial blood. Inside, 2 servo motors push the lower left and right parts of the heart outward in an offset sinusoidal rhythm, then quickly snap back. A 3rd servo moves the top part of the heart in sync with the lower section, completing the beating effect. The 3D printed heart is controlled by an Arduino microboard paired with an Adafruit I2S servo driver. A potentiometer allows users to adjust the heartbeat speed, and power is supplied through a cable in the back, enabling the heart to sit on a table or be held in the hands without disrupting the illusion. For those who find this version too realistic, Cogley also created a simpler model using a crank mechanism that gradually pushes out parts of the heart. This version is housed in a fabric heart-shaped shell and powered by a battery, making it more of a light-hearted gag than a realistic or frightening prop. But the ultra-realistic heart is not the only thing engineer Will Cogley can boast about. This skilled maker also 3D prints eerily realistic animatronic eyes. The key to making high-quality animatronics lies in lifelike movement and realistic finishes. You could have the most sophisticated actuator controls and mechanisms in the world, but the effect will be ruined if your character looks like a mannequin. On the other hand, a character that appears extremely lifelike when still can instantly fall into the uncanny valley once it starts moving. In this regard, the eyes are among the most important components, and YouTuber Will Cogley is making a series of films that will show you how to create animatronic eyes that are uncannily lifelike. In these videos, Cogley shows how to use inexpensive parts and 3D printed mechanisms to both create and operate the eyeballs. Any 3-dimensional printer that uses fused filament fabrication can produce all of the mechanical components.